Hello dear student, welcome to Physics Academy. This is our part 3 for Jest 2023 PIQ solution series. Okay, I hope previous lectures, which is basically based on 2023, and we in the previous lectures we have discussed a question from 7 to 16, and today's video I will discuss question 17 to question 25. Okay, and then आज के बाद हम लोग एक्चुअली जो सेक्शन 1 का पार्ट था, सेक्शन ए के पार्ट था जिसमें 25 क्वेश्चंस था, उस सारे 25 क्वेश्चंस का डिटेल डिस्कशंस हो जाएगा. ठीक है, तो आई थिंक you all are make your notes in proper way, right? And please make your note in proper way. If anyone feel too difficulty to understand what I am actually delivered to you, so please comment and or contact with me, message me. I will discuss what is the problems, what type of concept I actually use to deal this type of problems. Okay, don't worry about that, don't hesitate to share your problem with me. In my free time I will talk with you. I will deal with you that kind of problems. Okay, so don't hesitate. So here as usual, before आज का लेक्चर स्टार्ट करने से पहले हम लोग ये बोल देते हैं जो आज का सेशंस होगा बहुत ही खास होने वाला है, क्योंकि इस सेशन में क्वेश्चन नंबर 17 से लेकर क्वेश्चन नंबर 25 के बीच जितना सारा क्वेश्चंस एक्चुअली यहाँ पे हम लोग पिक किया ना, जो एक्चुअली एग्ज़ाम में दिया था, वो बहुत ही खास है, बहुत ही इंपॉर्टेंट है. क्योंकि इस टाइप का क्वेश्चंस आप देखोगे जेस्ट का एग्ज़ाम में बहुत बार पूछा है. तो क्वेश्चन 17 से लेकर क्वेश्चन 25 तक बहुत ही इंपॉर्टेंट क्वेश्चन दे आस्क एक्चुअली. सो दिस वीडियो इज़ वेरी इंपॉर्टेंट for your exam point of view. Okay, for your exam point of view, not for the knowledge point of view. This is for exam point of view, because this type of question they ask in many times. If you search paper from 2010 to 2024, then you will see that type of questions are they ask repeated form. Okay, so as usual, myself Mithun Patro. I am a PhD scholar at NISR ACPS, and I am working with exoplanet atmospheric characterizations with James Webb Space Telescope. Okay, so let's start our video. So okay, this is question number 17. Okay, this is question number 17. So in question number 17, two particles of mass m and 4m confined to move along the x-axis, okay, and are subjected to the force f of x equals to minus kx. Okay, they are subjected to force each others at time t equals to 0. The smaller mass m starts from rest at x1 t equals to 0 to a, and the larger mass starts from rest x2 t equals to 0 from minus a. Okay, the point on the x-axis where the first collision between the two particles is actually occurs. Okay, first of all you consider two particles. Okay, this is particle of smaller mass, this is particle of larger mass 4m, and they are confined to move along the x-axis. This is the x-axis. Okay, this is the x-axis, and they are confined to move. So small m particle moving along this direction, and larger mass particle moving along this direction, and they are collide each other at a particular point of x. Okay, and we are trying to calculate that point where they actually collide each others. Okay, and this small m particles starts from these positions, that is x1, that is t equals to 0, and 4m particle that is start from x2, this is equals to a, and that is x2 t equals to 0, that is equals to minus a. They are starting from their positions. Okay, I think I just make a mistake. This is consider m, and that is 4m. Okay, that is 4m, and that is 2, and that is plus 1. Okay, this is the actual good representation. This is a good representations. Okay, so these two particles are start from their own positions, on rest of the positions, and they collide at a particular time, at a particular point, and we are trying to calculate that points actually. Okay, and these two particles are subjected to a force, same force, f of x equals to minus kx. Okay, so two particles are subjected to sorry, extremely sorry. Yeah, two particle subjected to the force f of x equals to minus kx. This is equation 1. So determine the equation of motions. From the equation of motions, each mass execute simple harmonic motions. Okay, so hence each mass execute SHM. Okay, with the equations x of t equals to a cos omega t plus phi. This is equation 2, where omega is the angular frequency, and that is equals to actually k by m. Okay, and that is equation number 3. These are the very basic expressions I deal here. Now for mass m. Now for mass m. Okay, angular frequency omega 1 equals to k by m, that is equation number 4. For mass 2, mass 4m, okay, omega 2 equals to k upon 4m, that is equals to 1 by 2 k upon m, that is equals to omega 1 by 2. That is equation 5. That is the angular frequency of their oscillations. Now the initial conditions. Now set up the initial conditions for motions. Okay, initial conditions for motions. Initial conditions for motions. What is the initial conditions? For mass m, for mass m, x1 t equals to 0 equals to a. So x1t equals to a cos omega 1t. Okay, this is equation number 5. For mass 4m, x2 t equals to 0 equals to minus a. So x2 of t equals to minus a cos omega 2t, that is equals to minus a cos omega 1 by 2 into t. That is equation number 7. Okay, now find the collisions point. Next we calculate find the collision point. Find the collision point. Okay, two particles collide each other. It means the particle collide when x1t equals to x2t, right? So that is nothing but a cos omega 1t minus a cos omega 1 by 2 into t. So a cancel each other, a cancel each others, that is equals to cos omega 1t equals to minus cos omega 1 by 2 into t. Okay, so we are already know the basic identity. Cos theta equals to minus cos 180 degree minus theta, right? So cos theta equals to minus cos 180 degree minus theta. We use this identity here. We use this identity here. So from the equations we get omega 1t equals to 180 degree minus omega 1 by 2 into t. So finally we get omega 1t plus omega 1 by 2 into t into 180 degree. So that is equals to 3 by 2 omega 1t equals to 180 degree. So that is equals to t equals to 120 degree upon omega. So we get the time at which they collide each others. Okay, this is the time they collide each others. Okay, so finally we get out the positions. So okay, so positions x1t, that is equals to a cos t equals to 120 degree upon omega 1. So that is equals to cos 120 degree, and cos 120 degree is equals to minus half. So that is equals to minus a by 2. Okay, minus a by 2. So these two masses are actually collide each others at a particular time at this point. Okay, this is a very easy problem. This is class 12 problems actually. This type of problems they ask many times. This is the class 12 problems. So options B is the correct answer from the given questions. This is very easy questions. Okay, that's fine. Next we go to the question number 18. A point charge Q is located at the apex of the corner. This is the location of the point charge of height h and base radius h. Okay, base radius also h and height also h. The flux of the electric field through the cone due to the point charge. Okay. Flux of the electric field through the cone due to the point charge. Yeah, okay. We need to calculate the electric flux through a surface of a cone due to point charge Q located at its apex actually. Okay, actually we are trying to calculate the electric flux through the surface of the cone due to a point charge Q located at the its fx at the fx. So to calculate this, we use the Gauss's law, right? So what is the Gauss's law? We already know the Gauss's law. We start with basic form. To calculate this, we use the Gauss's law, right? So Gauss's law is equals to phi of E, electric flux that is equals to closed surface E dot ds, that is equals to Q enclosed by epsilon naught. Okay, so but in this case, or from this figure, in this case, entire Gaussian surface is not a closed surface, right? So write down the point here. Okay, in this case, this is equation number 1. Okay, in this case, the entire Gaussian surface is not closed. Obviously it is not closed, it's open cone. Gaussian surface is not closed, it is an open cone. Okay, so then what we do actually, so we need to determine the so we calculate the electric flux passing through the cone. Then we need to determine what fraction of the total flux passes through the cone. So our aim, as this is an open cone, so we need to calculate what fraction of the total flux passes through the cone. So we need to calculate what fractions of the total flux passes through the cone. Okay, that is very, very important because this is open cone. So next aim is our calculate the fractions of the flux through the cones. What fractions of the flux passing through the cone? That is our next task. So calculate now fractions of the flux through the cone. Okay, fraction of the flux through the cone. You know, total flux, we already know total flux due to point charge symmetrically enclosed in a sphere of radius r. We already know if a point charge q is symmetrically enclosed in a radius r, then total flux, the flux due to point charge enclosed in a sphere of radius r, total flux is actually q by epsilon naught. Okay, yeah, I know this is important, but in this case, for cone, for the cone, this is open, this is actually open parts, this is actually open surface. Okay, so flux, the flux passing through the cone, we are actually calculating what fraction of the flux passing through the cone. That is very, very important. So first of all, we calculate the solid angle subtended by the cone at the charge is actually located, right? First of all, we calculate that. This is the figure, no? This is the figure. Okay, this is h, radius also h, and we are calculate this is angle theta. and here is actually charge located. Now we first of all calculate the solid angle subtended by the cone at the charge is given by. So first of all we calculate the solid angle by the cone at the charge is located. H omega equals to integrations of d of omega, and that is equals to 0 to 2 pi d phi, 0 to theta, obviously theta, sin theta d theta. Okay, so that is equals to 2 pi minus cos theta 0 to theta, that is equals to 2 pi 1 minus cos theta. Okay, so solid angle subtended by the cone at the charge is located is equals to cos theta. Now from this geometry, okay, from this geometry we calculate the theta. So tan theta equals to h by h, so theta equals to tan inverse 1, so that is equals to 45 degree, that is equals to 45 degree. So solid angle subtended by, that is equals to 2 pi 1 minus cos 45 degree, so that is equals to 2 pi 1 minus 1 by root 2. Okay, so the solid angle subtended by this cone where actually this point charge is located, that is equals to 2 pi 1 minus root 2 1 by root 2. Okay, that's fine, that's fine. We know the total solid angle for a sphere, that is we are already know, right? Total solid angle for a sphere as we calculate, same process, 0 to 2 pi d phi 0 to theta, not theta, for sphere 0 to pi, okay, sin theta d theta, so that is equals to 2 pi 1 minus cos pi, so that is equals to 2, so that is equals to 4 pi. Okay, the total solid angle for a sphere. So what fraction? So fraction of the total flux that passes through the cone. What fractions? 4 pi में से flux passes हो रहा है through capital omega, right? एक sphere का total solid angle 4 pi था, उसमें से इस कैपिटल ओमेगा के थ्रू कितना फ्लक्स एक्चुअली पास हो रहा है, ठीक है, वो हम लोग कैलकुलेट करने वाले एक्चुअली. ओके, सो द फ्रैक्शन, तो इस टाइप का प्रॉब्लम ना कून के फॉर्म में अगर कोई फ्लक्स कैलकुलेट करने के लिए हो तब उसको सॉलिड एंगल का कॉन्सेप्ट लेके आना होगा. दैट इज वेरी गुड अप्रोच. द फ्रैक्शंस of the total flux that passes through the cone h omega upon 4 pi, that is equals to 2 pi upon 4 pi 1 minus 1 by root 2, so that is equals to 1 by 2 1 by root 2. Okay, so flux, so flux passing through this fraction of angle, fraction of angle, right? टोटल स्फीयर के लिए क्यू बाई एप्सिलॉन जीरो फ्लक्स पास हो रहा था, बट हम लोग क्या देखने वाले हैं, जो क्यू बाई एप्सिलॉन नॉट जीरो फ्लक्स फॉर ए सॉलिड स्फीयर पासिंग थ्रू दिस फ्रैक्शन ऑफ कोन, राइट? दिस इज द एग्जैक्ट आंसर. ओके, तो फ्लक्स through the cone h phi of e equals to q by epsilon naught into capital omega upon 4 pi. So q by 2 epsilon 1 minus 1 by root 2. This is the exact answer. So this is the flux passing through this cone. This is the flux passing through the cone actually. Okay, so this is very good, nice questions actually. That type of question they asked many times in your exam. That is very important question. Question number 19, this is for your homework questions. Please solve it, very easy type questions. Okay, this is your homework questions. Please solve it. Just calculate the curl and divergence. Okay, this is a first year type questions. It is not a very good, this is very not a good tough deal. I think this is not a tough deal. This is very easy deal. I think you deal it very easy way. Okay, so don't ignore it, don't skip it, please solve it in your copy. Next we go to the very good questions, that is asked from perturbation theory. Okay, this is asked from perturbation theory. Question number 20. Okay, that is nice questions. That is nice questions. Okay, okay, so we deal this type of questions in a good way. What is the questions actually? Consider a two-level quantum system described by the Hamiltonian h equals to h naught plus h prime, and h naught is equals to the given the unperturbed Hamiltonians and the perturbed Hamiltonian. This is unperturbed and this is unperturbed, and this is perturbed Hamiltonians. H prime is a small perturbations to the free Hamiltonian h naught. Epsilon is a small positive dimensionless number, and alpha, omega and capital tau have the dimension of energy, okay, and are the positive quantities. Okay, if we treat this problem perturbatively in a parameter epsilon, which of the following statements about the correction to ground state energy is true? Okay, they actually calculate the first order corrections and second order corrections of ground state energy. They want to calculate the first order correction and second order corrections for ground state energy. Okay, for ground state energy only, not for first excited state, not for second excited state. You know, this is the 2 cross 2 matrix or 2 cross 2 Hamiltonian, so we get two eigenvalues actually, ground state and first excited state, ground state and first excited state. But they want to calculate the correction, they want the correction to the ground state energy, they want to calculate the corrections for ground state energy. Okay, and correction of ground state energy for what kind of corrections? First order corrections and second order corrections, only for ground state energy. Be careful. Okay, only for ground state energy. Okay, so we have to calculate the first order correction and second order correction of ground state energy. Okay, now we calculate the step by step how to calculate the correction. So here first of all the unperturbed Hamiltonian is nothing but h prime equals to epsilon tau 0 1 1 0. This is perturbed Hamiltonian, sorry, this is perturbed Hamiltonian. Unperturbed Hamiltonians, H equals to, not H naught equals to alpha 1 0 0 1 plus omega upon 4 1 0 0 minus 1. This is unperturbed Hamiltonian. This is perturbed Hamiltonian and this is unperturbed Hamiltonian. Okay, so that is equals to alpha 0 1 0 alpha plus omega by 4 0 0 minus omega by 4, and that is equals to alpha plus omega by 4 0 0 alpha minus omega by 4. So this is the unperturbed Hamiltonian form, and it's like a identity matrix. Okay, so what is the eigenvalue or unperturbed energy level? So next we calculate the so next we calculate the eigenvalue. So these are nothing but the unperturbed energy levels. Okay, unperturbed energy levels. So that is equals to, first is the ground state energy, that is equals to alpha plus omega by 4. This is not ground state energy, this is first excited energy, and this is actually ground state energy. Okay, so this energy is the first excited state, and this is the ground state energy. Okay, and we have to calculate the corrections only for this energy. We have to calculate the corrections for this energy state using perturbation theory. First order corrections and second order corrections, two type of corrections we actually calculate. Similarly, as we know the eigenvalue, we can easily calculate the eigenstate for the given unperturbed Hamiltonians. So the eigenstate the eigenstates are this is for the 1 0, this is for E1 0 alpha plus omega by 4, and this is for state for 0 1 for E2 0 alpha minus omega 4, corresponding eigenvalue. These are the eigenstate from the corresponding eigenvalue. Okay, so this state is actually this is the state is corresponding to the ground state, right? This state corresponding to the ground state. Okay, so we have to use this. Now we calculate the first order energy corrections. We have to calculate the first order energy corrections. Okay, first order energy corrections. So we have perturbations, unperturbed potential, unperturbed Hamiltonians, that is nothing but epsilon tau 0 1 1 0. So we have to know the first order energy corrections. First order, the first order correction to the energy of the ground state. Energy of the ground state each. Ground state means this state. Energy of the ground state. This is the ground state. So that is equals to E2 1. This is the first order corrections. Okay. For the ground state energy, that is equals to 2 expectations value of this unperturbed Hamiltonian with respect to this ground state. Right. This is the exact formula. This is the expectations value of the unperturbed Hamiltonians with respect to this state. For ground state, if we here we calculate the correction of ground state, so that's why we use the ground state wave function, ground state. Okay, if we calculate the correction of first excited state, then you use the first excited state. Okay, don't worry about that. So this is the 0 1, so that is equals to 0 1, that is equals to so tau 0 1 1 0 0 1. Okay, now we have to multiply this, right? We have to multiply this 0 1 epsilon tau 0 1 no 0 1 1 0 0 1. Okay, 0 0 1, this is 1 1 0, that is 0. Okay, so epsilon tau equals to 0 1 1 0, so we get epsilon tau equals to 0 into 0, so that is equals to 0. So first order energy corrections of ground state is equals to 0. Okay, sorry. So first order energy corrections of the with respect to ground state energy have 0. Now we have to calculate the second order energy corrections. Second order energy corrections. Okay. Second order energy corrections. The same energy state, ground state. So second order energy corrections of ground state, it have a formula summations over n not equals to 2, that is 2 is the ground state, that is equals to mod of n unperturbed Hamiltonian ground state mod square, that is equals to E2 0 unperturbed energy minus En 0. But here we get only two state. Okay, one is the excited state, another is the ground state. This is the first excited state we get, and this is the ground state. Okay, so here have a conditions n not equals to 2, so we get only one combination is here, so that is equals to 1 h prime 2 mod square E2 grounds unperturbed ground state energy unperturbed first excited state energy. We already know this. So first of all, we calculate the this matrix term. Okay. Now that is equals to 1 h prime 2. Okay. That is equals to 1 0 1 0 epsilon tau 0 1, sorry, 0 1. Okay, 0 1 1 0 0 1. Okay. So that is equals to epsilon tau 1 0 and it's equals to 1 0. Okay. So that is equals to epsilon tau. So the matrix elements have a value epsilon tau, so that is equals to epsilon square tau square upon E20 unperturbed Hamiltonian, that is ground state, alpha minus omega by 4 minus alpha minus omega by 4. So alpha is cancel each other, so we get epsilon square tau square upon minus omega by 2. Yes or no? Omega by 2. So finally we got the answer. Okay, you now you have to match the option and you get the result for the second order energy corrections and the first order energy correction. So in this way we are calculate the first order energy corrections and second order energy corrections from the using perturbation theory. Okay, so these two formulas are very important. This is the formula for second order energy corrections, and this is the formula for first order energy corrections. Okay, so if I take a note for these two cases, first order energy corrections of the ground state energy, first order energy corrections of ground state energy have a formula for ground state energy for nth state. If I write a formula, first order energy corrections for nth state energy, okay, that is equals to n h prime n. This is the first order energy corrections. Okay, first order energy correction for nth state. Similarly, second order energy corrections for nth state, that is equals to summation over m not equals to n, and that is equals to m h prime n, and that is mod square en0 minus em0. Okay, em0, but here have a conditions m not equals to n. So this is the first order energy corrections. Okay, this is the first order and this is the second order energy corrections. Second order energy corrections. Okay, using perturbation theory. Okay, that's fine. Next we go to the question number 21 has been cancelled due to the some errors, so it's cancelled due to this error. So this is a wrong question. So this is wrong questions actually. Okay, this is wrong questions, so we have to go for 2020 question 2022. So how many because next question is how many independent real parameters, okay, how many independent real parameters are required to describe an arbitrary n cross n Hermitian matrix? What is the questions? How many independent real parameters are required? How many independent real parameters are required to describe an arbitrary n cross n matrix? So this type of questions, okay, this type of questions we deal with some example. Okay, with some example. Let us consider general from a 3 cross 3 Hermitian matrix. We consider from a 3 cross 3 Hermitian matrix. Okay, consider 3 cross 3 Hermitian matrix, not n cross n Hermitian matrix. Consider 3 cross 3 Hermitian matrix. Okay, so what is the 3 cross 3 Hermitian matrix? This is the general form: A C plus ID, E plus IF. Okay, C minus ID, that is B, that is G plus IH, and that is equals to E minus IF, G minus IH, and that is equals to C. This is the Hermitian matrix. So here A B C D, A B D, here actually A B, oh sorry, not C here, not C here. What is D? A B D, A B D. What is this? A B D are the real diagonal element, right? These are the all real diagonal element. And for off diagonal complex element, if we consider the off diagonal, these are the off diagonal, these all are the off diagonal, right, off diagonal complex element. So its off diagonal element, each off diagonal element has a real part as well as imaginary part. Okay, real part and imaginary part. But this off diagonal elements, if we consider one off diagonal element C plus ID, okay, if I take a one off diagonal element C plus ID, this is the off diagonal element, and this off diagonal elements have a two real number, right? This is two real number. Okay, this is the one real number and this is the another real number, C and D, two real number, C and D, right? This is the for off diagonal element. Similarly, for E plus IF, this is a complex number, okay, but it's a two real number, E or F. Similarly, for G plus IH, this off diagonal element have two real number, that is G, H. So each complex element contribute two independent real numbers. Okay, so each complex element contribute two independent real number. Okay, okay, so two independent real number we count since each complex number contribute two independent real number. Yes or no? Are you understand the point? So for the diagonal element we get 3 independent real number, and the complex element, from the complex element we get 2. Contribute for each complex number we get 2 independent real number. Okay, are you sure? Are you clear? So how many real number, how many independent real number is here? So total real number, so total real number, total independent real number is equals to 3 from diagonal plus 3 into 2, that is for complex of diagonal. So that is equals to 3 plus 6, 9. Okay, 9. So for 3 cross 3 matrix we get 9 independent real number. Now this is for n cross n matrix. If you go for n cross n matrix, if we go with n cross n, if we go with n cross n Hermitian matrix, then we have n real diagonal element. Yes, और क्या होगा, और n into total elements n square, उसमें से n number of elements are, this is the total elements, total elements of Hermitian matrix, real plus diagonal plus octagonal, and this is the diagonal elements. So this is nothing but the remaining elements. Okay, so this is the remaining element. From these remaining elements, we take only, from these remaining elements we take only n into n minus 1 by 2 complex of diagonal elements, and each so this is the n into n minus 1. If you notice here, the total 6 of diagonal elements. From this 6 of diagonal element we consider only 3 elements. Okay, but because these 3 are this have the same C or D, same real number. Okay, so we consider only real independent real number, that's why. So this is the remaining element. So from these remaining elements we consider only n into n minus 1 by 2 complex of diagonal element, and from this n into n minus 1 by 2 complex of diagonal element, each contributing 2 real number, right? Yes. So each element contributing two real number. Two real number. Okay. So total number of real number is equals to n plus n into n minus 1 by 2 into 2. So that is equals to n plus n square minus n plus n square minus n cancel out, so that is equals to n square. So for a Hermitian matrix, total independent real parameters, so this is nothing but total independent real parameters. This is the total independent real parameters for Hermitian matrix. Okay, n square. For n cross n matrix, total number of independent real parameter n square. For 3 cross this matrix, total number of independent real parameters is 3 square. Okay, be careful about that. Okay, next go for 23. Next go for 23. That is another nice questions. This type of questions they ask in every year from probability theory. Two paired dice, two paired six-faced dice, two paired six-faced dice thrown simultaneously. Okay, two paired dice thrown simultaneously. The probability that one of the dice yields an outcome that is a multiple of 2 and other yields the multiple of 3. Okay, there are two dice, right? Have a two dice, sorry. Okay, so the two dice. From this outcome, this is have a outcome multiple of 2. And from this dice outcome multiple of 3. So what is the probability for that? Okay, so in this dice, so the possible outcome, the multiple of 2, the possible outcome two, 4, 6. So that is the 3 numbers. Okay, possible outcome three or 6. This is a 2 number. This is a 3 number. For that case, 3 numbers. In that case, we get 2 numbers. Okay. So since we have a 2 dice, one should be multiple of 2 and other a multiple of 3. Now count the valid case. Okay. The first die is a multiple of 2 and second die is a multiple of 3. So first die has a 3 choice, 2, 4, 6. Second die has a 2 choice, 3 and 6. So total case for this event, total case for this event is equals to 3 plus 2, 6. Okay. If I change the die, now first die is a multiple of 3. First die is a multiple of 3, and second die is a multiple of 2. In first case, first die is a multiple of, sorry, I repeat the case actually. First die is a multiple of 2 and second die is a multiple of 3. Okay, so similarly first die, second die. So first die, the multiple of 2, so outcome I think multiple of, right, some पहले सही था. Okay, sorry यार, multiple of 3 and multiple of 2, पहले सही था. I am wrong. Multiple of 3, so 3 and 6, outcome 2, 4, 6. So total case for this event, two into 3, that is 6. Okay, so the total number of favorable outcome for these two event, total number of favorable outcomes, 6 plus 6. Okay, and the total possible outcome when now total favorable outcome, now the total possible outcome when rolling 2 dice, when rolling 2 dice is equals to 6 into 6, that is 36. So the probability 36 out of 12 out of 36, right? So that is equals to 1 by 3. So this is the probability, right? So this type of questions is very nice questions in your exam point of view. Okay, right. So please remember this outcomes. Not to remember. Please be careful when dealing this type of problems. Okay, so if you not calculate the second part, second event, you got the wrong answers. You got the answer option A, right? You got the option A because we don't know. They are not identify the this is not specify this dice. From this dice we get only only the outcomes of multiple of 2. They not specify. They just say we have a 2 dice and we get outcome like that. One dice have outcomes multiple of 2, another dice have an outcome multiple of 2. So they in the question paper they do not specify that this is the dice number A and this is the dice number B, and especially in for dice B we get only this kind of outcome, and this is the dice A, and for this dice we get this kind of outcome. No, they just mention we have a 2 dice and the outcomes are right like that. So that's why the second event, considering the second event is also important. Okay, so be careful when you deal this type of problems. Be careful. If they set the restrictions, then okay. If they are not set that kind of restrictions, you just open your mind and try to thinking and try to solve that kind of problems in a better way. Okay, yeah, next go to question number 24. That is very easy questions. Convert the octal number to decimal equivalent. Yeah, we know the form octal to decimal conversions. Octal to decimal conversion. Octal to decimal. So decimal I have rules. D to the power n into 8 to the power n, Tn-1, 8 to the power n minus 1 plus the result d1 to the power 1 plus t0 into 8 to the power 0. This is the actual conversion from decimal to octal to decimal. So here 3237208. So we have to convert this in decimal number. This is octal number. We have to convert decimal number. So for 3 into 0 1 2 3. Okay, 8 into 3 plus 7, 8 into 2 plus 2, 8 into 1 plus 0, 8 into 0. Okay, so just calculate this one by one each value. So 3 into 512 plus 7 into 64 plus 2 into 8. So finally we get 1536 plus 448 plus solo, and that is equals to, if you sum of this all this value, that is equals to 2000. Okay, 2000. So the decimal equivalent from 3708 0, this is the octal number, to decimal equivalent. is that. And from decimal to binary we have to calculate again this. It's very easy. So this type of questions is very easy. So please, when you take notes, please also calculate. This is your homework part. This decimal number to binary number. What is the binary number? Okay, please calculate and comment in my channel. Okay, please calculate and comment in my channel. So that type of questions is very important. Decimal to binary, how to calculate decimal to binary, decimal to octal to decimal, decimal to binary. This is the actual way to calculate each and every case. Okay, yeah, that's fine. Okay, that is the last questions for today's video. Is steam engine takes steam from a boiler at 200 degrees centigrade and pressure and exhausts directly into the air at 100 degree centigrade and pressure 10 to the 5 Pascal. The maximum possible efficiency is close to. Okay, this is very easy question. This is from the Carnot engine, right? This is from the Carnot engine. So the source and sink, source temperature and sink temperature you already know. This is the source, no, not source. This is the source, this is the sink, and say source temperature T1 is equals to 200 degrees centigrade plus 73. So for that is equals to 473 Kelvin, and T2 the sink temperature 100 plus 273, so 373 Kelvin. So we have to calculate the maximum possible efficiency in a closed Jest 2. It's very easy questions, right? So eta equals to 1 minus T2 upon T1, temperature of sink upon temperature of source. So 1 minus 373 upon 473. So that is equals to 0.789, that is equals to 0.21, that is equals to 21%. So this is very easy questions. I think this is very easy questions they are asked in the exam. So when you dealing with problems, so please read the Carnot engine in proper way, in details. Okay. So what are your tasks now? अभी तुम लोगों को क्या करना होगा? ओके, अभी तुम लोगों को क्या करना होगा? देखो, सारे प्रॉब्लम्स हम लोग 25 तक तो सॉल्व तो कर लिया. अभी तुमको क्या करना होगा? जितना सारा 1 by 1 प्रॉब्लम पूछा है, ठीक है, एक एक प्रॉब्लम का जो थ्योरी है, एक एक प्रॉब्लम का थ्योरी को आपको अच्छे से डील करना है. इसमें से आपको पर्टर्बेशन थ्योरी का प्रॉब्लम्स अच्छे से पढ़ना होगा. पर्टर्बेशन थ्योरी का प्रॉब्लम्स आपको एक मिला है, तो पर्टर्बेशन थ्योरी को एक बार डिटेल्स आपको एक बार गो थ्रू कर लेना है. अगर किसी स्टूडेंट को पर्टर्बेशन थ्योरी से कुछ प्रॉब्लम्स है, आप चैनल में कमेंट करिए, मैं उसके ऊपर वीडियो लेके आऊँगा. ओके, जिस भी टॉपिक्स में से इस 25 क्वेश्चन में जो टॉपिक के में से आपको कुछ डाउट हो रहा है, मैं उसी टॉपिक्स में से वीडियो लेके आऊँगा अगर लोगों का प्रॉब्लम होता है तो. ठीक है, तो आज का वीडियो इतना तक ही है. तो इसमें हम लोग 2023 का पार्ट ए वाला सेक्शन हम लोग कंप्लीट किया. नेक्स्ट वीक, इस वीक में हम लोग पार्ट बी और पार्ट सी, इस दोनों को कंप्लीट करने की कोशिश करेंगे. ठीक है, डिटेल सोल्यूशन हम लोग देने की कोशिश करेंगे. तो जो आपका प्रिपरेशन है बहुत हेल्प होने वाला है. सो each questions is very important for a preparations. If you calculate every questions in proper way for the 5 or 4 years का questions, तो आपका एग्ज़ाम बहुत ही अच्छे से निकल जाएगा. ठीक है, ऐसे कोई मतलब तुमको एक एक क्वेश्चन को सॉल्व करना है, उस रिलेटेड थ्योरी को भी एक बार पढ़ लेना है. कैसे आया है, कार्नोट इंजन से क्वेश्चंस मिला है, तो आपको क्या करना होगा, उस कार्नोट इंजन को एक बार पढ़ लेना है. थ्योरी को पेन आपका नोट हो, आपको जहाँ से आपके पढ़ाई किए थे उसको एक बार गो थ्रू करके रिवीजन कर लेना है. इसी तरह मान लो जैसा आपको 24 का क्वेश्चन है, ठीक है, 24 का क्वेश्चन में क्या है, देखो, ऑक्टल नंबर टू बाइनरी नंबर टू डेसिमल नंबर, इस तरह के कुछ चेंज रिलेटेड क्वेश्चन है। तो आपको एक बार कॉपी को देखना है, आपका नोट्स को एक बार देखना है, इलेक्ट्रॉनिक्स का नोट देखना है, उसमें से ये जो सारे रूल्स है एक बार जस्ट आपको गो थ्रू कर लेना है, ठीक है। इससे क्या होगा, आपको सेक्शन से एक बार स्ट्रॉन्ग, आपका जो फाउंडेशन हो इससे स्ट्रॉन्ग होने स्टार्ट हो जाएगा। आप जस्ट इसी क्वेश्चंस को सॉल्व करके रख दोगे तो आपके लिए बहुत ही अच्छा नहीं है आपका प्रिपरेशन में। आपको थोड़ा बहुत क्या करना होगा, उसी पर्टिकुलर जगह से एक बार आपको पढ़ लेना है। हाँ, ये जो प्रोबेबिलिटी वाला पार्ट है इसमें से इसी प्रोबेबिलिटी रिलेटेड आपके पास थ्योरी है, उस थ्योरी को एक बार गो थ्रू कर लो। उसके आसपास कुछ एक्सेप्शनल रिलेटेड प्रॉब्लम होता है, उस प्रॉब्लम को भी एक बार गो थ्रू कर लो। जैसे जो हर्मिशन मैट्रिक्स मैंने लिखा इधर, तो इस हर्मिशन मैट्रिक्स को भी एक बार पढ़ लो ना। ऐसे करके पढ़ोगे तो हर्मिशन मैट्रिक्स रिलेटेड और भी कुछ प्रॉपर्टीज़ है, तो उसको भी एक बार आप माइंड में आपको रिकॉल कर लोगे, पढ़ लोगे, तो एक बार गो थ्रू कर लोगे तो आपको डिटेल्स प्रिपरेशन ऐसे करके प्रिपरेशन होना चाहिए, ठीक है। क्वेश्चंस के थ्रू आपको प्रिपरेशन होना चाहिए। जैसे जैसे पार्टिसिपेशन थ्योरी का ही प्रॉब्लम्स है, तो आप एक बार पार्टिसिपेशन थ्योरी का डिटेल्स पढ़ लो, फर्स्ट ऑर्डर करेक्शन, सेकंड ऑर्डर करेक्शंस, एनर्जी करेक्शंस, वेव फंक्शंस करेक्शंस, तो उसको फॉर्मूला को भी एक बार याद लोग होना चाहिए। आपका डिटेल्स थ्योरी एक बार याद हो जाएगा तो आपको बहुत ही यूज होगा। तो आप एक एक क्वेश्चन से एक एक क्वेश्चन आप सिर्फ सॉल्व नहीं कर रहे हो, उसके साथ साथ आप थ्योरी को रिविजन कर रहे हो, तो ये इंपॉर्टेंट है। अभी तुम लोगों का जेएस का एग्ज़ाम फॉर्म फिलअप स्टार्ट नहीं हुआ है, ठीक है, स्टार्ट हो जाएगा। एक बार फॉर्म फिलअप स्टार्ट हो जाएगा तो एग्ज़ाम भी आ जाएगा, तो इससे वेरी होने का कोई दिक्कत नहीं है। आप अपना प्रिपरेशन में बस फोकस करते रहिए, आप अच्छे से फोकस करिए। आप लोगों के लिए अच्छा है ना, आपको एग्ज़ाम थोड़ा सा लेट हो रहा है, आप लोगों को पढ़ने के लिए मौका मिल रहा है इस तरह का हाईली कम्पिटिटिव एग्ज़ाम, जेस्ट एग्ज़ाम, ठीक है, जिसके आपको एक इंटीग्रेटेड पीएचडी वाला ऑप्शन मिलने वाला है इंडिया का बेस्ट इंस्टीट्यूट में, जिससे आपको कुछ सैलरी भी आपको मिलेगा। दैट्स इंपॉर्टेंट, दैट्स फाइन। सो आपके पास अपॉर्चुनिटीज़ है, आपको इसको अच्छे से ग्रैब करिए, इसको अच्छे से प्रेपरेशन करते चलिए। मौका है, इस मौका को आप हाथ से बाहर जाने मत दीजिए, आप इसको ग्रैब करने के लिए कोशिश करिए, हार्डवर्क करिए, वही इंपॉर्टेंट है। बस ऐसा मतलब आपका फॉर्म फिलअप स्टार्ट ही नहीं हुआ, नहीं ऐसा नहीं, आप प्रिपरेशन करते रहिए। आप एवरी वीक एवरी डे आप 6 से 7 आवर सी के ऊपर फोकस करते पढ़ते रहिए, आपको ज़्यादा पढ़ने की जरूरत नहीं है। 6 से 7 आवर एवरी डे अगर क्वेश्चन सॉल्व करोगे और उस पर्टिकुलर क्वेश्चन के रिलेटेड जो थ्योरी है, तो थ्योरी को एक बार अच्छे से गो थ्रू करके चलोगे तो अच्छे से प्रिपरेशन हो जाएगा, ठीक है। इतना भी हाई लेवल से थ्योरी से नहीं देता है लोग, मास्टर डिग्री से क्वेश्चन नहीं देते, जस्ट बेसिक से देता है, ठीक है। जस्ट आप अच्छे से पढ़ोगे तो हो जाएगा जस्ट का एग्ज़ाम भी, ओके, ठीक है। थैंक यू फॉर वॉचिंग दिस वीडियो एंड प्लीज़ लाइक एंड सब्सक्राइब दिस चैनल।